Hey guys, welcome back to my channel. Today we're gonna talk about human voice sound waves. But first, have you ever wondered why is it that we hear our voices different than other people? But before answering that, we're gonna see how vocal folds work. In voice speech, the vocal folds, sometimes misleadingly called vocal cords, vibrate. This allows puffs of air to pass, which produces sound waves. Vocal folds are folds of membranous tissue that project inward from the sides of the larynx to form a slit across the glottis in the throat, and whose edges vibrate in the airstream to produce a voice. The human voice is a broadband sound, meaning it has a mixture of different frequencies. This allows us to divide speech sounds into voiced, meaning that the vocal folds vibrate, and unvoiced. When you're younger, the vocal folds are short and thin, so your voice is high-pitched. But when you're older, they become larger and thicker, so your voice gets deeper. Sound waves are sine waves, which are a mathematical curve that describes a smooth periodic oscillation. A sine wave is a continuous wave. Wavelength is the distance between the crests of the wave. Then we have amplitude, which is the maximum displacement or distance moved and the amount of energy. Then there's the frequency, which is the number of waves that pass a fixed place in a given amount of time. For the math analysis, I wanted to calculate the wavelength of a human voice sound wave with a frequency of 130 Hz. First, we start with a formula which is velocity is equal to frequency times lambda. Since we want to find the wavelength, we're gonna switch around the equation and use lambda is equal to velocity over frequency. The velocity of all sound is 343 meters per second, and the frequency of the voice I wanted to use was 130 Hz. This would mean that the wavelength of this human voice sound wave would be 2.6385 nanometers. Usually, the female voice has a higher pitch and the male voice has a lower pitch. Pitch is the quality of a sound governed by the rate of vibrations producing it, the degree of highness or the lowness of a tone. Here we have a female and a male voice. The female is a high-pitched voice and the male is a low-pitched voice. They both are saying A, E, I, O, U, and I recorded the wavelengths and the frequencies of each of them. One thing that's very noticeable is that the female voice has a much higher frequency than the male voice. This is why it's much more high-pitched. Going back to our initial question of why our voices sound different to us and to other people, this is because when other people hear our voice, the sound vibrations enter their ear and into their eardrum, and so that's why the voice is more sharp and strong. And when we hear our own voice, it's because the internal bone vibrations resonate in our skull and change the perception of our voice, which makes it sound softer and lower. Well, that's it for today, guys. Thank you so much for watching. Make sure you give it a like and subscribe and comment down what you have learned today. Bye!